Hi, and welcome back, everybody. In this video, we're going to be taking a look at the distance formula and using that to figure out an equation of a circle. So let's jump right in and start talking about the distance formula. Now, in order to do that, I've got 3 points that I've graphed here on this coordinate plane, point A, point B, and point C. And the first thing we're going to do is just look at the coordinates of all 3 points. Now remember, a point's coordinates, it's an ordered pair with an x coordinate and a y coordinate, right? So each one of these has an x and a y, and they correspond to the location of that point above or below the x-axis, and then to the right or to the left of the y-axis. So for instance, A is above the point, the value of 3 on the x-axis, so it has an x-coordinate of 3, and it is to the right of 4 on the y-axis, so it has a y-coordinate of 4, so A is at 3, 4. B would be at 3, negative 3, because it's below 3 and to the right of negative 3, so it's 3, negative 3. And C would have a value of negative 6, 4, because it's above negative 6 on the x-axis, and it's straight over to the left of 4 on the y-axis. So negative 6, 4. And then the next thing I want to take a look at is, well, what's the distance between A and C and the distance between A and B? So the distance between A and C could be thought of as the length of a segment that connects A to C, right? So if I draw a red segment here, if I'm looking for the distance between A and C, it would be the length of that segment. And since A and C are kind of on the same horizontal grid line, I can just count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. I can see that's 9 boxes. Or maybe mathematically what I can do, I forgot to write the coordinates of C here. It was negative 6, 4. Mathematically what I could do is, since they are at the same place on the y-axis, since they both have a y-coordinate of 4, the distance that they are apart would just be the difference between their x-coordinates. So I could take negative 6 minus 3, find the difference between negative 6 and 3. That would give me negative 9. But of course, since I don't really want to think of this as a negative answer because it's a distance, I'll just take the absolute value of that and call it 9. Same answer I got by counting the boxes, right? Now if I'm looking for the distance between A and B, it can be thought of as the length of this vertical segment right here that connects A to B. Again, since this is a vertical segment, it means that the A and B both have the same x-coordinate. They're both an x-coordinate of 3. So I can count the boxes, 1, 2, 3, 4, 5, 6, 7. Or mathematically what I could do is look at their y-coordinates and find the difference between a y-coordinate of 4 for A and a y-coordinate of negative 3 for B. So 4 minus negative 3, that'll give me 7. And since that's already a positive number, I don't worry about taking the absolute value of it, right? So the distance from A to C is 9, and the distance from A to B is 7. Well, now what about if I wanted to find the distance from B to C, right? What if I wanted to find, and of course this is going to be a little bit trickier to draw, these diagonal lines are a little bit trickier to draw on my drawing pad here, but I wanted to find this distance from C to B, all right? The distance of that turquoise line there. Of course, I can't just count the boxes because some of the boxes, I'm kind of going diagonally through them, so it's not exactly going to be one unit as I go across some of these boxes, right? So how am I going to find that distance? And some of you can probably see the answer, right? If I scroll this up a little bit, give myself some room to work. Since the red segment and the purple segment would be perpendicular, this triangle that they form all three together is a right triangle. So I can use the Pythagorean theorem to find this missing distance d, right? I can say that the 9 squared plus the 7 squared will equal d squared. So 9 squared plus 7 squared would be 81 plus 49 for d squared. And that's going to be 130 equal to d squared. So d is the square root of 130, which is about 11.4. All right, so that's how we could find the distance from B to C that way. Or what we can use is something called the distance formula. So let's take a look at what the distance formula says. It tells us that the distance d between 2 points that we're going to call x1, y1 and x2, y2. Now notice that doesn't mean x squared, y squared. It means, x1 means the coordinate of the x coordinate for the first point and the y coordinate for the first point. x2 and y2 are the x coordinate for second point, y coordinate for second point. The distance between those 2 points can be thought of as d would equal the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now that looks pretty big and ugly, right? It's got this big, huge square root. It's got some things subtracted, then squared, added together, then squared. But I want you to notice in a minute here, you're going to see that this is actually basically, it's the same thing as the Pythagorean theorem. It's not really any different than doing the Pythagorean theorem. Another way to think of this, by the way, would be the distance is equal to the change in x. Now that looks like the triangle symbol that we've been dealing with in geometry, but it's actually the letter delta, the Greek letter delta, that stands for change in. That's usually used to denote the change in a value from one measurement to another. So the change in x squared plus the change in y squared, and then take the square root of those two things added together. So let me show you what I mean. This is basically the Pythagorean theorem up here. Since I was finding the distance between B and C, let's call C's, so C was the coordinate -6, 4. Let's pretend that that's x1 and y1. B, which was 3, -3, we'll say that's x2 and y2, right? So you can see I've kind of connected these numbers to these x1, y1s, x2, y2s that we use in here. Now the distance formula would tell us that to find the distance, I'm going to take the change in the x's. So I'll take, and really actually, even though I listed it x2 minus x1 and y2 minus y1, it doesn't matter which order you do it in. The squared right here is actually going to take care of the difference between doing it x1 minus x2 or x2 minus x1. So, but I'll just to kind of stick with what I wrote down here, I'll do x2, which is 3, minus x1, which is -6, and I'm going to square that, plus y2, which is -3, minus y1, and I'm going to square that. So what this simplifies to is the square root of 3 minus -6 is 3 plus 6, or 9. -3 plus -4 is -7, and I'm going to square both of those things. And so hopefully you can start to see how this is similar to what I did here, right? This 9 up here in the graph is just how far apart. So here's the x coordinate for C, and then right here is the x coordinate for B. So it's that length of that red segment there is how far apart the x's are for the 2 points B and C. The purple segment is how far apart are the y coordinates for A, which is for C, which was up here, and the y coordinate for B, which is right there. So that's that purple segment there is the difference between the y coordinates for C and B. And we already figured those out to be 9 and 7, so we got 9 squared, and we got -7, but when I square it, it's going to become a positive number. So D is going to be the square root of 81 plus 49, which is the square root of 130, which is about 11.4, which is what I found over here using the Pythagorean theorem. So you can see it's really based off the Pythagorean theorem. Let's take a look at a couple examples of using the distance formula. So I have a point M and N, a point M at -3, 8, and N at 2, 4. Now if I just quickly sketch out, let's just quickly sketch out a coordinate plane just to get an idea where these points are. M is at -3, -8, so -1, 2, 3, and then down 1, 2, 3, 4, 5, 6, 7, 8. So M would be right about there. N is at 2, 4, 1, 2, 1, 2, 3, 4. So it's right about there. So this is the distance I'm looking for, right? So I'll change colors real quick. And this is the distance I'm looking for, right there. Right there. Now, according to my formula, and I'm going to use this kind of shortened version down here. That distance is going to be the square root of the difference in the x's squared plus the difference in the y's squared. So the difference in the x's, let's start there. That means going from negative 3 right here, right, over here to positive 2. That's where the n is, and that's where the m is. Or you could think of it as, if I just drop this value, this x value for n down to here, and kind of connect it over here, I'm looking for this distance right here. It's from negative 3 over to 2. Well, how far is it from negative 3? How far is it from negative 3 to 2? Well, it's going to be 3 units to go from negative 3 to 0. Or look down here. From negative 3 to 0 will be 3 units. And then I got 2 more to get over here to positive 2. So 3 and a 2 is going to be a 5. So that change in x is 5. So I'm going to square that. Plus, how about changes in y's? So I'm going from up here at positive 4 down here to negative 8. So it's this distance right here, right? That's our difference in our y's. How far is that? Well, from positive 4 down to 0 would be a distance of 4. And then from 0 down to negative 8 is a distance of 8. So altogether, that is a distance of 12. So our difference in the x's, the difference between negative 3 and positive 2 is 5. The difference in the y's, that's negative 8 to positive 4, that's a 12, right? Because it takes 8 units to go from negative 8 to 0, and then 4 more to go from 0 to 4. So that's a total of 12 units going from negative 8 to 4. So now I have the distance would be the square root of 25 plus 144. So that's the square root of 169. And that comes out nice and neat as a 13. Now you'll notice what I could have done there is once I had this sketch, is I could have looked and said, okay, this is 5, 3 and 2, so this distance is 5, and this distance right here would be a 12, and this is a right angle, so I could have done 5 squared plus 12 squared equals d squared, but that's essentially what I did, right? 5 squared plus 12 squared, and then I took the square root of it. So let's look at example B real quick. I want to do this one without drawing the sketch. I want to see if I can do this one just kind of by thinking about what the formula is telling me. So the distance is going to be the change in x squared plus the change in y squared. So now going from negative 1 to 5, that's our change in x, right? Going from negative 1 to 5, well, from negative 1 to 0 would be a 1, and then from 0 on over to 5 is 5 more, so 1 plus 5, that would be a total of 6, a change in 6 going from negative 1 to 5. So I'm going to square that. Now let's figure out the change in y's, going from 8 down to negative 3. Well, from 8 to 0 is 8 units, and then down another 3 to get to negative 3, so that would be a total of 11 units going down from 8 to negative 3. So that's an 11 squared. So now we're looking at the square root of 36 plus 121, which is the square root of 157. And let's see, does 157 simplify? I don't think that it does. Not simplify into a nicer square root. So we can leave it as square root 157, or we can type in our calculator and get an answer of about 12.5 as a decimal. Okay, that's going to do it for this part of the video. The next part, part 2, is going to be looking at how the distance formula applies to the equation of a circle. So we'll see you again in that